Hello guys, welcome to Mr. Moses practical session on Physics 107. So today I will be taking us on a switch ride into the simple pendulum experiment, and the aim of our practical is to determine the acceleration due to gravity. So in this experiment, we will be using the simple pendulum experiment to determine the acceleration due to gravity g, which we know to have a numeric value of 9.8 meters per second squared. So for this experiment, what we'll be using is our simple pendulum experiment set up in the laboratory, which consists of our pendulum bulb, our light thread, our retort stand, our half meter rule, or if you have long meter rule you can use it, and also our stopwatch. So these experiments will be able to help us to find out the acceleration due to gravity. So follow me as I take us on this switch ride. So guys, the simple pendulum experiment is an experiment that relates the length of the pendulum bulb to the period of oscillation. So what is the period of oscillation? The period of oscillation is the time it takes to complete one full oscillation. And what is one full oscillation? A complete movement of the pendulum bulb to and fro, front and back. So the time it takes to complete one full oscillation is called what? The period. So in the simple pendulum experiment, there are basically three procedures. First of all, you ensure you set up the apparatus like this. Then the second one is to vary the length of the pendulum, which you can see here, the length of the pendulum bulb with the period of oscillation. So first we are going to start with our first length, which is going to be 50 centimeter. So I will measure 50 centimeter of the pendulum bulb. Okay, now the next thing is I will take my stopwatch, then I will reset the timer to 0. Then what I will do next is I will tilt this, I will displace it a little bit, then I will displace it a little bit. Then after displacement, I'm going to displace this a little bit, then start the stopwatch immediately so that I will be able to record the time it takes to complete 10 oscillations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and I will record this my time first as my T1. Okay, then I will do it again, reset the timer, then I will displace it again a little. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I will record the second time to be my T2. Now I will reduce the length because I remember I said that what we do is we vary the length of the simple pendulum with the period of oscillation. So next I will take this to 40 centimeter. I'm going to reduce it to 40 centimeter. Okay, then I will carry out the same procedure again. Displace it a little. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I will make out my time T1 for 40 centimeter. Then I will do this same experiment for 30 centimeter, 20 centimeter, and 10 centimeter for this practical. So after carrying out this procedure, then the next thing is for you to compute your value. After computing your value, you plot a graph of L against T square. By so doing, you'll be able to take your slope, which is going to give you a straight line graph. So after plotting out your value, you will be able to find the acceleration due to gravity g for the simple pendulum using the formula which I'll be showing us shortly. pendulum experiment. This is the table of value and how it should look like. We have our length L in centimeters, our time T1, which is the first time recorded for the period of 10 oscillations. Then the time T2 is the time for the second time recorded for 10 oscillations, and mean time T is going to be T1 plus T2 all over 2. Then the period T is going to be the mean time T all over 10, which is the period for one oscillation. So then after that you will compute your T square. That means your time raised to power the period of oscillation T raised to power 2. So that's just that. And the next thing we do is we plot a graph of L, that means the length of the pendulum bulb, against T square. Just as I said that the simple pendulum particle is a particle that gives us a variation between the length of the pendulum bulb and the period of oscillation. Now the second thing is that we determine the slope of the graph, and if we determine the slope of this graph, the slope of the graph is going to give us L over T square. Then we can be able to compute our G, which is the acceleration due to gravity. G will be equal to 4 pi square or 4 pi square L all over T square. Then if we insert our value of our slope, because from this graph we have that our slope is going to give us L over T square. Our slope is going to give us L over T square, so that if we insert our values, we will have that our G is equals to 4 pi square multiplied by our slope. 4 pi squared multiplied by our slope. So this is what it will give us. So our G is going to be 4 pi square multiplied by the slope. Okay guys, that's that for our stable pendulum practical. So go ahead, plot your graph, take your readings, and if you are having any issue with the practical procedures, ensure you put a comment in the comment section. So you can go ahead and subscribe, click on the subscribe button so that you will see more of our posts whenever any practical is being sent into the platform. See you guys in our next practical session. Bye bye.